Hello and welcome to Math Lessons with Linda. Today we're going to cover a quadratic word problem and how we would interpret our equation and then answer some questions regarding the formula that we're given. So today's is regarding a ball toss. A ball is thrown in the air and modeled by the equation h equals negative t squared plus 8t, where t equals the time and h equals the height. So the first thing I'm going to notice is that when I have a negative in front of my quadratic term, my squared term, what that tells me is that this would model a parabola that is upside down. So I know that something like this is happening. Somebody is standing, there's a ball, it gets thrown into the air, it is going up, it reaches this high point, and then because of gravity, it's going to come back down again. So let's keep that in mind when we are going through our problem. So the first thing that we are going to find is what is the maximum height, right? How high does the ball get? So what that means is that I need to find this vertex of my parabola, right? So the ball is going up, it hits up here, it gets to the highest point, and then it's going to come back down. So there's an easy way that we can figure out what this maximum height is. So what I'm going to do is remember that our vertex is like an HK point. And the H represents, our independent variable, our K represents our dependent variable. So for this, I can use this little shortcut for quadratics to find the X, which in this case is kind of like our H. It gives me this first part of the vertex. And so I'm going to substitute in the B and the A values. So remember that the A value comes from the coefficient of your squared term. So that's -1. The B comes from the next term, which is 8. So I'm going to do the opposite of B. B was 8, so now it is -8. And over 2 times -1. So I get -8 over -2. And this is 4. So what I've actually found here is how long the ball's in the air, right? Because my H value for my vertex is taking the place of my independent variable. So this really tells me the ball is in the air for 4 seconds. So I'm going to take this value that I now found and I'm going to substitute it in to my formula because I need the height and I know my time is 4. So let's plug that in. So H equals, I'm going to plug in, remember the negative is outside, it is not in the parentheses. So it's going to be negative outside and then 4 squared plus 8 times 4. So 4 squared is 16. I get -16 plus 32. And if I add that, I get 16. So what that tells me is that the height that the ball gets to, the max height, is 16 probably feet. Okay, so I know that this is 16. All right, so now I know that the ball has been in the air for 4 seconds when it reaches this maximum height, right? So this is the vertex of my parabola, which is 416. Right? So that's how long the ball has been in the air when it reaches 16. All right? So now we have another question to answer. So part B, where is the height of the ball 0 feet? Okay, so here we're looking for time. At what time is the ball at a 0 height? So let's think what that means. That means, when is the ball on the ground? So here's the ground, right? So the ball is on the ground at the beginning and at the end. And I just want to know what time that is. So what I'm gonna do is go back to my equation, h equals negative t squared plus 8t. And it says, where is the height 0? So I'm gonna make the height 0. So now I have a relatively straightforward quadratic to solve. Because on here, since there's only two terms, they each have a t, I'm just gonna factor out a t as a GCF. So I have t out here, I have a negative t left, and now a plus 8. Here are my two factors. In a quadratic, once I have it factored and it's equal to 0, I set each of these equal to 0 to solve. So one of them is t equals 0. That was easy, and we knew that it had to be 0 here because of what our graph looks like. So what's the time over here? Well, I'm gonna do negative t plus 8 equals 0. And the easiest thing to do is to add a t to both sides to make that positive. So at time 8 seconds, that's over here at my end point, right? So here where time is 0 and here where time is 8, those are the two places where the height of the ball is 0. And this makes sense. Remember that our vertex was 4 seconds at 16 for the max height? This should be a symmetric graph, and there are 4 seconds in between each of these start and end points. So that is one example of how to use quadratic functions and solving word problems.